Good evening, guys. So today I want to teach you how to write systems of equations in non-slope intercept situations. Notice I say write and not solve. Today we're just going to write them. If you even want to add that in your title, please do so. Make this the page on the next free page and then close it up. Clear out those distractions, turn up that brain, and off we'll go. So last time we dealt with systems of equations in scenarios where we were given an initial value and a rate of change. Easy to make those two facts into slope-intercept form, and very easy for us to make graphs from slope-intercept situations. In this case here, Marianne and Carlos are saving for new scooters. Their savings are shown. So Marianne, we have an equation here. It's in, notice, slope-intercept form. So we know her initial value or her starting amount is $10, and the slope or the rate at which she saves is $6 per hour. And then Carlos down here, his graph's already drawn. He's got an initial value of 2. We can calculate his slope in 1 more hour. He earns, how many is that? 2 up to 10, looks like $8 more. So his has a slope of 8, and his graph's already there. And it was very easy to solve a system of equations when we had that info, because now we can do Marianne's as well. She starts at 10. Sorry, this is kind of teeny. And each hour she saves $6 more. So 1 more hour, 2 for $6 more. 1 more hour, 2 for $6 more. 1 more hour, $6 more. 1 more hour, 2 for, there's my answer, $6 more. 1, 2, 3. And so her line would look about like that. And we would know that they'd have the same amount of money right here. After 4 hours, they would both have $32. And that was great. It was in slope-intercept form. We know what to do with that. We know what to do with that. Pretty easy to do. What about situations like this today? Stop and read it for a moment, and then I'll talk about what I mean. So you'll notice what's different here is say, okay, well, what are my initial values? What are my y-intercepts going to be? Does it give anything that says starting with or before or anything like that? It does not. And when I graph these, what is my slope going to be? I don't see anything that sounds like slope. I just see sort of two things being sold here. And if instead of getting initial value and slope, from which it's easy to write things in slope-intercept form, you're just given two things, two items, two objects, two things like that, it's actually easy to write your equations in standard form from those situations. So I'm not even going to try to write a slope-intercept form equation. I'm just going to use some common sense, and then what you're going to notice is my equations like turn out in standard form. So that's what I see. I see popcorn and I see drinks. So those are kind of the two things we don't know. How many popcorn buckets, how many drinks? I'm going to call those P and D, or I can call them X and Y. I'll do X and Y. We usually do X and Y, so I'm just going to do X and Y. So I'm going to X be the popcorn buckets and Y be the number of drinks they buy. So what I see in this first sentence, 2 popcorn buckets and 4 drinks for $20. That means however many popcorn buckets they bought. Oh, there's 2. I'm sorry, however much they cost. So 2 times however much the popcorn costs, plus 4 times however much the drinks cost, add up to $20. Very common sense equation. 2 times this plus 4 times this equals $20. It's right there in the sentence. And you'll notice I get an equation in standard form. Other situation I have, our other person bought 2 popcorn buckets and 2 drinks for $14. So second equation, 2 times however much the popcorn costs plus 4 times however much the drink costs. When I add those two costs up, I'll get $14, and voila, we have a system of equations. We're not going to solve it today. Not going to graph it today. Could, don't want to. You'll notice the big difference today is this situation. We were given different types of information than we were usually given, and we wrote a different type of equation in standard form. Let's do one together. If you'll pause here and write these in your notebook, I would appreciate it. So again, today we're not going to solve. We're just going to write the system of equations. Today we'll solve it another day. Here's what I can do with this. So the first thing I'm trying to do is decide on my variables. That's there. So we're going to do adults. We're going to call, I guess, A in this situation. And however many child tickets are called C. And so right away I see that, right? So however many adult tickets times 15 plus however many child tickets times 10, $10 per ticket, $15 per ticket, that's going to add up to $225. There's my first equation. What's my other one? The other one's a little sneaky here. The other piece, remember I've got this. A is how many adult tickets, C is how many child tickets. The other clue I have is this, 20 tickets total. So however many adult tickets and however many child tickets were purchased, together that's 20 tickets. Voila, system of equations. And it's in standard form. Okay. Here's the thing to add. Here's the big deal about it, right? You'll notice in the situation, no initial value or unit rate is given. And if no initial value or unit rate are given, slope-intercept form is not a possibility. Got to kind of cross that out. You cannot write equations in slope-intercept form unless you're given a slope and y-intercept. We were not here. Instead, we were just kind of, I call it like a two things equation. We're just given two things. And when you're just given two things, standard form is easy to do and makes lots of sense. So y'all, that is how to write a system of equations when you do not have an initial value or a unit rate given to you. Hope that made tons of sense, and we will solve these tomorrow. If you need to go back and review because you zoned out or missed something, please do. See you later.